In this particular question, we are told that we have a rigid square coil of side 60 mm and 50 turns. So it hangs vertically so that we can rotate freely about one side, and when a current of 0.4 amperes passes through the coil, it hangs at an angle of 30 degrees to the vertical, with its lower side in the vertical magnetic field of the magnet. The weight of the coil is then 0.12 newtons. So if we draw the free body diagram of the coil, we realize that we have the magnetic force acting downwards, we have the weight acting downwards, and we have the reaction force at the pivot. However, we are not going to concern ourselves too much with the reaction force at the pivot, because this is quite clearly a moments question. I'm going to let the length of this entire coil be L, and L has been given to us as 60 mm. So our task now is to find what is FB. Question tells us that the weight of the coil is 0.12 newtons, and this angle over here is 30 degrees. So by taking moments, about the pivot, which is here, we have force times this perpendicular distance over here, which is going to be L over 2 sine of 30 degrees. So 0.12 times L over 2 sine 30. And basically this is responsible for the anti-clockwise moment. On the other hand, we have the magnetic force, FB, which is responsible for the clockwise moment. And his perpendicular distance is going to be this distance back to the pivot over here, which is going to be L cos 30 degrees. Now, solving for FB, we obtain 0.0346 newtons. Now from here, if we use the formula FB equals to NBIL, and we go ahead and solve for B, we can sub in the values of FB, which is 0.0346, divided by N, which is 50 turns, multiplied by I, which is 0.4 amperes, multiplied by the length that is exposed to the magnetic field, and since it's a square, it's also going to be 60 millimeters, so it's 0.06 meters. And thus, our answer is going to be 0.029 Teslas. And so, our answer is A.